Today, let's quickly prove the 6 equations. First, we prove the product rule. When hx is equal to fx times gx, and see the goal is hx derivative of h of x is equal to fx times derivative of g of x and plus f derivative of f of x times g of x. This is our goal. And let's see first, we say limit delta x approaching 0, h of x plus delta x minus hx over delta x equal limit delta x approaching 0, f x plus delta x times g of x plus delta x minus f of x times g of x over delta x equal. Now let's see how do we see the next step. And let's focus here, this part, to C, to here, our goal. What do we need to turn to here? Our class. We can let this part to do what? In the first write limit x approaching 0. Okay, let's see. Here, we let this part. F of x plus delta x times g of x plus delta x. This part. We let this part do minus. Minus what? Minus f of x plus delta x times gx. And plus f of x plus delta x and times gx. And then minus f of x times g of x. Okay, over that x. Okay, now let's see the upside. The numerator, let's see here. Let's see. We can make it to this part and this part. Right? Okay, so let's see. So we can here limit. We can change it to 2 parts. Limit delta x approaching 0. Okay, first let's see. Actually, in here and upside here in this part, let's see. We can take the f x plus delta x out. So we can got g of x plus delta x minus g of x over delta x. Actually, this is another form of the derivative of g of x. This is another form of this. So let's work it out. It actually should be f of x plus delta x this over 4. So over delta x. And let's see. This part, let's take the gx out. If we take the gx out, actually f of x plus delta x minus fx over delta x is another form of the derivative of f of x. So let's see. It's plus limit delta x approaching 0. And that's f of x plus delta x minus fx over delta x. gx. Naughty. So after we limit it here, limit it, and then we will go up. Yeah. And this is because limit, you see, if it's limit, so the delta x will be dx, and dx you can't see because it's smaller than the delta. So you can't see it, so that's equal to 0. You can look at it, that's equal to 0, so we can write it is fx. fx. Now what's this? You see, I said about 4, it's another form. If it's limit, delta x approaching 0, actually this part is limit delta x approaching 0, this part, then times limit and delta x approaching 0, this part. And just limit delta x approaching 0, this part is derivative of gx. And let's see here, right? See, it's the same sign, right? So it should be plus f of x derivative of f of x times g of x. And g of x. Okay, so that we prove the product rule, and let's prove the quotient rule. Okay, let's prove the quotient rule. Quotient rule. Okay, so let's see. Quotient rule is hx. Of course, they're still the same. Okay, hx equal f of x over g of x. Let's see the goal. Okay, hx derivative equal fx the derivative of f of x gx times gx minus f of x times derivative of g of x. Okay, over g of x squared. Okay, this is the goal, and let's prove it. Okay, it's the same. Let's prove it. So it's limit that x approaching 0 h of x plus delta x minus x. Okay, let's see what we're doing. And then we reduction the fractions to a common denominator. Okay, so of course, I like the numerator here, like doing that. Okay, of course I can put the delta x up right here. Okay, that's much more clearly. Okay, clearly. Okay, should be Okay, numerator is what? Sorry, it's the denominator. Denominator is g of x plus delta x, and then g of x, and times x. Okay. And what's the numerator? It's f of x plus delta x times gx, and minus f of x times g of x times plus delta x. Okay, and we got this. So you see, let's see. Outside you see f of x plus delta x. You can change it to f of x plus delta x minus f of x. So, and another plus f of x. Okay, so let me write it down, okay? Okay, sorry. Here I lost the limit. Okay. So let's see here. First let's limit to the x approaching 0. And what? Let's see here. F x. Oh, sorry, it's f of x plus delta x. Here, and let's see. Practice this one minus f of x. Practice g of x. Like that. And minus, sorry, it's plus. Plus f of x times g of x. And then let's minus f of x times bracket g of x plus delta x and minus g of x. Bracket, and then what? Then minus f of x times g of x. So you see, here I have a positive f of x times g of x, and then I have a negative f of x times g of x. So let's go and cancel it out. Right? Okay. So, sorry, I forget to say write the denominator. Should be practice and x. Okay. Let's see. Hey, did you see? We've already solved the goals denominator, right? So let's see. After we limit delta x approaching 0, this part 1 over this part, and we can got what? And we can got this, and we can. So we just write himself in the first limit part, okay? 1 over g of x plus delta x, and then gx. 1 over. Okay. Let's see. Times, practice, limit. And what? Let's see. So what did we left, right? Let's see. We left here, right? Okay. Let's see. Actually, we can turn it to 2 parts. One part is here. And another part is here. divide delta x. So what's that? Let's see, okay? Let's see. This one divide delta x. Actually, this is another form of the derivative of f of x. And this part, divide delta x, is another form of derivative of g of x, right? Okay, so let's see. We can still make the two parts. That's why I write brackets, because they have a part minus a part, right? Okay, let's see. Should be limit delta x approaching 0 and y. Well, f of x plus delta x minus f of x over delta x times g of x minus limit delta x approaching 0. The f of x times g of x plus delta x minus g of x over delta x. Bracket. So let's see. Of course. Now we can what? Now, okay. I don't write the answer, right? You know that, right? This part is the denominator of this goal, and this part is the numerator of this goal, and we have the problem, right? Okay, I don't write it. Okay, so actually it has another way to solve this problem. This problem. Let's see. Actually, because you see, we have proved the product rule, right? We have proved the product rule. So we need to prove the quotient rule, and let's see. Hey, you see fx over gx. So you can, it's equal to fx times g of x to the negative 1. Of course, this negative 1 is just a power. It's not means the inverse. Okay, it means the power. Okay. Okay. Let's use this one. Okay. Let's see. It's fx times factor g of x factor 1 factor and plus fx g okay, let's see this one. Hey, this, if I want to do, this one is derivative of cos. It's a chain rule, right? So equal to fx what? Fx what? Fx times negative 1 times g of x to the negative 2 and times g of x derivative and what? And plus fx derivative times g of x to the negative 1. Okay, let's see. Let's make it fractions, right? Okay, so let me let these two to be the same fractions. Right? I just write it in the answer because you see, of course, this one's fraction denominator is a gx squared. So we alternate to gx squared. Gx squared. And let's see. should be upside because see, I'm making 1. So we put in the back, okay? And we put this first because this denominator is gx. So we need to turn it into gx squared. So it should be fx derivative of f of x times g of x. And minus f of x times derivative of g of x. Okay, so we can use this way or this way to prove the quotient rule.